Hi kids, today we're going to talk about graphing attributes. If you remember from last week, an attribute is a characteristic or something that a figure has. So we talked about words like vertex, which was the point where the edges meet. We talked about edges, which were where two faces meet. We talked about faces, which were the flat side of a figure. And we talked about curved surfaces, which are, if you put the figure on its side, it could roll, or it wasn't flat, so it wasn't going to stay flat, it could roll away. So a graph, if you remember, always has a title. So look at our graph here. This is a bar graph, and its title is Faces on Solids. So this graph is going to be about how many faces do these solid figures have. So in a few minutes, you're going to be turning to your workbook, page 313, which you can do so now and follow along with me if you like. And we're still going to go up at this helper box and take a look at this example. So for example, this is a pyramid. If you remember, a pyramid has a square at the bottom and its sides are made of triangles, comes to a point at the top. So this one, it says how many faces on this solid. Remember, the bottom is 1, and then it has 4 sides. So you have 1, 2, 3, 4 triangles on either side, to the 2 you can't see plus the 1 on the bottom. So you're going to have 5 faces on this pyramid. So you would color 5 boxes. 1, 2, 3, 4, 5. Okay, so this is a cylinder. How many faces does the cylinder have? Well, a cylinder technically has 0 faces. Honestly, I had to call a math teacher and ask about that because I would say it has 2. I'm not going to tell you you're wrong if you tell me that a cylinder has 2 faces because it has a flat top and a flat bottom. I think in first grade math, this makes sense to me. I think when you get to junior high, they can tell you differently. So in my first grade mind, the book is wrong, and this should be 2 faces for this cylinder. This is a rectangular prism. It looks like a Kleenex box. So if you have a Kleenex box, you can grab it with me, and you can count the faces. So it's got a square on one side and a square on the other side that you can't really see. So that's 2. And then it's got 4 faces all the way around, 1, 2, and then the back and the bottom that you can't see. So it has a total of 6 faces on this rectangular prism. So you would color 6 boxes. 1, 2, 3, 4, 5, 6. Okay, remember, when you're graphing boxes, you start at the number 0. The first full box that you draw or you color in is going to be a 1. And you color 1 box for each face. Okay, and so it's giving you steps here for the bar graph. So you title and label the bar graph. Let's take a look. Okay, you're going to be tracing today. So this is just helping you. Tomorrow, you're going to do this again on the back side. And I'm pretty sure you're going to have to use this page as a guidance to help you remember what that you need to do. So you title and label the bar graph. So here's the title, Sides of Plane Figures, because that is what we're graphing today. Here are the plane figures that you're going to be graphing. Plane figures are not solids. These are just flat figures. So you have, this is a 1, 2, 3 sides. It's a triangle. This one, 2, 3, 4, 5. It's a pentagon. 1, 2, 3, 4. It's not a rectangle. It's slanted, so that's a rhombus. And this is 1, 2, 3, 4, 5, 6. A hexagon. Okay, I gave you a big clue right there because you're going to be counting sides of these plane figures. So it gives you the example of a hexagon. Okay. Oh, and here's your numbers. Here's 0. 0 means that you didn't color in a box yet. So the first full box will be 1. And you keep labeling each line on the number line until all the way you get to 10. So 10 boxes total across. Are you going to be counting 10 sides on a figure? I don't think so. Fun little fact, a figure with 10 sides is called a nonagon, or decagon. A decagon. Isn't that an interesting word? Decagon, like decade is 10 years. A decagon is a figure with 10 sides, which I've never seen before. And if you can find one and show me, I'll give you some extra credit. So let's look at this. It's got 1, 2, 3, 4, 5, 6 sides. So you're going to trace this figure because we trace, and you're going to color in how many boxes? 1, 2, 3, 4, 5, 6 boxes because it has 6 sides. 1, 2, 3, 4, 5, 6. Color these in. I know they're done for you. Color them in anyway. That's what we do. So you're going to do that for your rhombus and your pentagon and your triangle on your own. Don't forget, you have to trace the title, trace the figures whose sides you're accounting, and trace the numbers on the number line. Practice lining up your numbers. You guys can cross off number 2 today. Yay! But it does say, how will your bar graph be different if you replace the triangle with a trapezoid? So a trapezoid, do you remember what it looks like? I wish I had a pen to show you. I don't have a pen right here. No, that doesn't work because that is a rectangle. So a trapezoid is almost like a rectangle, except it has a short top and a long bottom, and its sides are slanted up a little bit. So the important thing you should take away from this is I just said that a trapezoid has 4 sides. 4 sides. So it says, how will your bar graph be different if you replace the triangle with the trapezoid? So you're going to be replacing a figure with 3 sides and giving it a figure with 4 sides. This is a rectangle, not a trapezoid. My mouse isn't that cool. So just something to think about. If 1, 2, 3 sides, so 1, 2, 3 for the triangle. If this had 4 sides, how would this bar graph be different? So something for you to think about, something for you to talk about. So go ahead and get started and create your bar graph for sides of plane figures. And that's it for math today. Miss you guys. Hope you're having a good day. If you have any questions about this, drop me a message and I'll get back to you. Bye.